So talk about email. For those of you who don't know me, I'm Rick Cygnus. You might know me by RJBS on CPAN or IRC or mailing lists or Flickr or I don't know, on the internet. That's me. I maintain a bunch of email modules on the CPAN. A lot of email modules. And I work for a company called Pobox, and all we do is email. And we've been doing email since a long time ago. And I deal a lot with email. So I'm going to talk to you today about some of the email standards that exist, the way they govern the way that email works and is formatted, and paying special attention to some of the more troublesome cases in handling email. But the most important thing that you need to know about email is that email hates you and it wants you to suffer. This is my favorite quote, I think, from all the email RFCs. This is from the RFC that introduces modern multi-part messages. This is strange and baroque, and compatibility is always favored over elegance. This is the understatement of the century. If you were wondering why you should care about this, you don't really need to know any of this. And this talk isn't going to teach you how to do this effectively. It's not going to make you a better programmer. It's not going to teach you the right way to construct an RFC 2183 content disposition header. The one important thing you might learn here is that your code sucks. And I'm really serious about this, and I mean it about my own code too. If you have written code that handles email, that gets email in from the outside world and tries to read it, if you've written code that makes email and sends it to the outside world, you did it wrong. I'm not saying probably, because I know you did it wrong. And I can tell you how I know. It's impossible to get it right. The standards get it wrong. The main implementations get it wrong. And that means that doing it right is going to be wrong because you can't actually receive real email. For God's sake, stop writing code that deals with email. There exists a small initiative called the Perl Email Project. We maintain most of the code that starts with email : and a bunch of the code that starts with other stuff like MIME and mail. And last year I gave a big talk about the various problems that the Perl Email Project's code has, but the basic fundamental issue is it's never going to work. So here are the things you need to know up front. There's something called Email Simple. Should you use it? Probably not. Email Simple is okay if you're just building a new message and not reading one off disk or that someone else has produced. If it's got a plain ASCII 7-bit body, and there's no chance that any variable you're putting in there, any input you've gotten from anywhere has 8 bits, and it's not a reply to an existing message, and the people you're sending it to, you only have their email address and not their real name to put in there. So if these are all true, maybe this is a good tool. Then there's Email MIME, which is a little better. It can produce more forms of valid email, but it's still going to get them wrong all the time. And what's going to happen at the other end? There's MIME Entity. MIME Entity is a little more accurate than that. It's kind of got a weird interface, and it's got a lot of old scariness in it, but it's a little better. And then there's Mail Message, which is the 900-pound elephant of, that's pretty light for an elephant. It's the 10-ton elephant, if you will, mail handling modules. It gets most things pretty darn right, but it's big and scary, and people object to it because they think that email is simple, but it's not. There is one more reason that you might care about this, and that's spammers. Email is so hard to parse properly that it's really easy to abuse parsers with malicious input. So if you want to obscure malicious mail that you're sending to somebody, all you have to do is make completely valid mail that most tolerable parsers still can't figure out. I'll point some of these out as we go. So the question is, why is email so crazy? Why is it so completely horrible and insane? Some people think that it goes all the way back to RFC 822 and RFC 821, which brought this madness into the public eye in about 1982, but this isn't true. No one's really sure how long email has been completely insane. But if you look back to RFCs 561, 680, email actually made a lot of sense. It was simple, anybody could write a parser, there was nothing to it. But then we got RFC 724. And this is where things really got crazy. it introduced this thing called header folding. And header folding was a way of saying, look, sometimes I've got a header on my message. We all know what an email header is, right? So we got a header on this message, and it's really long. It won't fit on my little Wise terminal. But I want to be able to read it without scrolling over, and I don't want to write a presentation layer to figure out how to wrap it. So we're going to put it in the data layer. So if you've got a header like this, and let's pretend now and for the rest of these slides that this is a really narrow terminal. So we need to wrap this. Header folding lets us say we can write this. We can find a place to put a line break and some indentation, and it means the same thing. So this and this are, in the terms of RFC 724, lexically equivalent. But you know, we don't need to stop there. If we've got a really narrow terminal, this is fine too. There's no reason we can't write that. That's completely legal. Is this ridiculous? Well, yeah, it's completely ridiculous, but it doesn't matter, because you're going to find email that contains this. You're going to find content that contains all this kind of nonsense all the time. And what's worse, half the time you see this, the person will be completely in the wrong. And half the time you see it, they'll be completely valid. And you won't be able to figure it out, because you can't figure out what's valid and what's not. You basically have to accept everything. So going back to folding, when can we fold? Well, we can fold basically whenever we want, as long as it's a valid place for linear white space. So when is linear white space valid? RFC 724 says linear white space can be freely inserted in reasonable places. It really says that. It also says that in addition to the parser that reads the tokens in your email, the existence of another lexical analyzer is assumed, of course. So anywhere you want. And what this actually turns out to mean, anytime two tokens meet, anytime there are two tokens next to each other in an email message, you may add space. And that space, any kind of space is equivalent. And there's a special kind of space called a comment. And comments nest. When a comment is used to act as a delimiter between any two things, it's treated just like one space for the purpose of understanding what happened. So when you're trying to understand the content, this is just the same as this, or this. This is basically, and I shouldn't even say basically, this is for all intents and purposes lexically equivalent to that. It's a really good thing we added folding, right? Because, I mean, could you imagine having to scroll to the right to read that? This is a lot clearer. If you ever want to see an email programmer cry and see his eyes glaze over with rage and desperation, just ask him about comment or folding whitespace. Comment or folding whitespace is the name given to this monstrosity by RFC 2822, the modern email format. And it tries to limit the effects of CFWS, but it's not very effective. So for example, this is still completely allowed, but helpfully, this is not. This was valid in RFC 822 and 724, but no longer. RFC 2822 says no lines that are only white space, so thank you. But that's enough of that, right? Let's talk about some other headers we see a lot. Email gets date headers. In fact, every email message is required to have a date header that tells you when the mail was composed and sent. Here's a pretty standard date header. You know, that's a day, in a month, in a year, at a time, with a time zone. That's pretty reasonable. You know, these days we probably want to use ISO 8601, but nobody can say that's completely insane. You can also write this. This is another form that's completely acceptable. You can write this if you want to. We added a little more space because, hey, why not? This is valid too. A lot of people think this is really bizarre, and I guess I'm one of them. D there is the military time zone, which is something like, and I'm sure I'm going to get this wrong, A through M are increasing hours west of Greenwich, and Z is Greenwich, and N through Y or something are hours to the other side of Greenwich. So this is completely valid because, you know, the military wants to use the internet. And here's another form, totally valid. We can use these things pretty completely. So, okay, it's silly. It's a little too flexible, but, you know, writing a parser for this in Perl is not a huge exercise. The only problem is that in addition to these forms, we can write this. Because, right, they're just tokens. We can put comments in there. And this is totally valid, right? No, this isn't valid at all. Comments can't be empty. Okay, 2822 once again steps in, and it says, look, this comment folding white space thing is crazy. You guys are, it was a bad idea, we're really sorry. You can still have comments, I guess you might need them, but you can only put them at the end. Okay, right, they're only at the end. The only problem is, if you want to parse 2822, you still need to parse 822, which means, yeah, that's still good. And the reason is, if you look at 2822, you're going to expect a grammar that looks something like this. All the old RFCs use sort of pseudo-grammar. Some of them start to become more like BNF over time. And we say, you know, a date is a day, and a month, and a year, and a day is 1 or 2 digits, and a month is one of these 3-character month abbreviations in English, and a year is 4 digits. Okay. The problem is the way it actually looks is like this. A day is 1 or 2 digits, or the obsolete day. And the month is January, February, or the obsolete month. So, you know, how do you obsolete a month? You know, what's an obsolete? Well, an obsolete month is a month with comment folding white space on either side of it. And if you want to know, you know, is this like what does obsolete mean? Well, the term is anything that is obsolete must be accepted and parsed. Way to go. So this is a pretty bad RFC. Wow. The AD system is trying to protect you. This is a pretty bad RFC, and all we've talked about so far is the header. You know, things are going to get pretty bad, aren't they? This isn't going to be good. Well, this is what a message looks like. A message is the headers, or maybe the headers and then a blank line and the message text. Sorry, that's going to be really, really bad. Huh, okay. I can buy that, right? It's a bunch of ASCII characters. That's all you need to understand. So everything crazy is in the headers, right? Right? 821 is all about how to send mail. It replaces things like UUCP, FTP. There's a lot of RFCs that talk about how to use FTP to send mail, which is pretty great. 821 calls this the Simple Mail Transfer Protocol, and like all the best names, it is a lie. In SMTP, lines can't be more than 1,000 characters long, and that's including the trailing CRLF. And there's no folding for long lines like we had for headers. And there's no encoding for 8-bit characters. So the solution, obviously, is don't use 8-bit characters. Hear me, Europe? Stop it. Well, then they introduced MIME. MIME is a way to do multi-part messages. It's a way to do messages that are in 8 bits. It's a way to do all kinds of crazy stuff. It's RFC 1341, which isn't really the first thing that gives us MIME. RFC 934 comes before, which is fairly simple. I mean, it only includes text like, when the forwarding agent encapsulates a message, it should apply the following finite state automaton. Seriously? 1049 is other prior art for this, and I'd love to say bad things about it, but one of its top-level MIME parts is trough, and that forgives a lot. 1341's not too bad until you get to section 7, where they define a new SGML-compatible markup language for making formatted email. This gets replaced pretty quickly with RFC 2045 through 2049. 5 RFCs defining the new world of MIME. So let's say we want to send this message. Well, we can't, right? It's got 8-bit characters in it. We can't send this over SMTP, and even if we could, it's not a valid message because a message body is 7 bits. So what we need to do is declare that we've encoded the body for transport. And we say that by saying, here's a content transfer encoding. We're using base 64 here. Base 64 is just a way of taking a 8-bit string, more or less, and turning it into 7 bits. So this isn't quite enough though, right? Because all this is giving us bytes. And this is something that a lot of us Americans and even other Europeans who use the fairly similar alphabets can ignore a lot because we think that it's all the same, but really this is what we put in there. We didn't put that text in there, we put these bytes in. What character set is this? Because if I was typing in UTF-8, what gets put in an email are these bytes. And if your email program doesn't know the character set and guesses that it's Latin 1, you're going to see this. But if you're on a Mac, you're going to see this. And neither of those is a very good exhortation towards our God. So we're going to just need to throw some more metadata in here. And we're going to say there's a content type, which is plain text, and that it's in UTF-8. So now you know how to get things back out. And this is fairly reasonable. There is one little quirk, which is that this is exactly the same message. Because anytime you find characters in your base 64 that are not valid base 64 digits, you quietly ignore them. So you can just, you can put all the 8-bit data you want in there as long as you have some 8-bit transport mechanism, and it's still a completely valid email message. Kind of, because it says that we have to ignore any of these non-base 64 characters, except maybe we want to reject them under some circumstances. To be fair, this does predate RFC 2119, which is where they tell us, please say must or must not. What does this really mean in practice? Nobody knows. If you send a message that has some crap in it, maybe it'll work, maybe it won't. Maybe somebody can read it, maybe they can't. Spammers can really get behind this system, because let's say they want to send you this message. Well, any crappy content filter, your little proc mail filters that drops mail that looks for lines that contain Viagra, well, it's going to catch that, but it won't catch this. And when you write email code that parses the body by slurping up the lines of the body, you have failed. And everyone does this. But let's get back to the subject at hand. We've got this message, and we want to encode it another way. This is a really human-readable way. This doesn't have the problem of base 64. It has a different problem. We've encoded this in binary, which means it's the literal bytes of the message. So this is basically what we had before, except we've explicitly said we didn't encode it, and now we can't send it over SMTP. So that's no good. So let's compromise. We're going to introduce another kind of encoding called quoted printable. This is, we can kind of read some of this message. We can see there's some words here. We see the quote signs. Only things that we've escaped are the 8-bit characters. Some encoding systems or programs that are doing this encoding don't know exactly what's legal and what's not. So they go a step further and they just, they encode bunches of stuff. So it's still somewhere between base 64 and legible. There's some crap in there. We've encoded the spaces now. Really, there's no reason we can't encode any bytes we want. But there's one thing we can't do. We can't do this. I've got a message here, and we've got a bunch of line breaks. You see there's a line break right there after the equals 20 bracket. And a line break is just a CRLF. So I've got CRLF, CRLF, and then back to text. So you'd think I could encode those, right? And say, well, I've got CRLF, CRLF. It's wrong. It's not illegal, and it's not invalid. It's just kind of wrong. And the reason is that in quoted printable, it's not just the bytes that matter. It's the meaning of what you're saying. See, if I put a literal CRLF there, it means that I want a new line when you display the message. But if I encode the CRLF, it means that I want the CR byte and the LF byte. So if your mail program is going to get this message, well, this is going to display like this, because it is a new line. But if I send you this message, your mail program is expected to display this. Mutt does that. And just to take a second, before you think that I'm sort of having a lot of fun here, I've encountered this bug numerous times. There is a lot of software out there in the wild that will do this to your email. Okay, but let's just take a step back. These email specs suck. They have to be ignored. Let's take a breath, ignore this problem, and move on. Okay, so we've got this message. We've encoded it. It's quoted printable. Only the bytes that have to be encoded. This is not so bad right now. Now, one issue here is all we've got in the from and to headers are the email addresses that we're sending to, but we want to include the people's real names so that things show up nicely in inbox listings. So that's going to be easy. All we basically do here is we put quotes around the name, and we put some angle brackets around the email address, and that's perfectly valid. And we just keep going. That's not going to work because Vlad's name there, that's not 7-bit characters. So how do we fix that? We can't use content transfer encoding, right? Because that only refers to what's in the body. So we need another way to encode stuff. So we're going to use encoded words. Encoded word is a new token introduced by RFC 2047, and it's just like a word, but it's encoded. That means it starts with equals question mark, it ends with equals question mark, and there's two question marks in the middle. Okay, so let's deal with this, right? Here's this one email header we want to send. Let's just encode it. So, there we go. Equals question mark, then the character set, then a question mark, then a single character indicating how it has been encoded, then a question mark, and then the encoded string, then question mark equals. Q here, between some of those question marks, means quoted printable. Remember I mentioned quoted printable before? Yeah, this is different. This is the other quoted printable. And here, we've got another 8-bit name, and we're going to encode it some other way. A different character set, different encoding. The B here is base 64. This base 64 is the same one, so great. Unfortunately, the name we actually had in our database for this guy, we have it in 3 fields, and they're encoded differently. So we're going to say, well, his first name is this encoded word. And then we've got this other word, which doesn't need to be encoded, it's 7-bit. And then we've got something in EBCDIC, and then his email address. This is totally legal. His name, which is lexically one string, can be in a bunch of different incompatible formats. We can stick them all together, and it becomes the reader agent's problem. Another thing we can do is we can take this guy's name, and even though it's completely 7-bit, for the sake of sanity, or perhaps because we're scumbag spammers, we can encode that too. But this actually is no good. Anybody have a guess? It's because you can't have a space in there. Encoded words can't contain spaces, because then you don't know when the encoded word could stop. So we use an underscore instead of a space. And that is one of the reasons that this is not normal coded printable. In normal coded printable, underscore is underscore. In this coded printable, underscore is space. Great. Let's put it under the rug and keep going. So here's our message. We've got 4 encodings in this message. Sometimes they're a little different, or 4 char sets, sometimes 2 char sets in one string. Before Unicode, you can never decode this, but okay, this is fine. It's not going to get any worse. Okay, we can put comments, of course, between any 2 parts of a string, and those will get dropped out. And did I mention that comments, while they are white space, are structured white space? I mean, obvious, right? Because how do you know that you can nest them? And you can put encoded words inside of comments. So, okay. Here's our message. And we can tell by looking at this message that it's a reply to something, right? We see the little subject says, Ray, blah, 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 blah. So what was it in reply to? Here's the original message. It's the weekly newsletter. And as you can see, there's going to be an attachment. But unfortunately, in the world of email programming, attachments don't just pop onto your screen like little documents. They have to be encoded because, it's going to be 8-bit. So what does this look like as an encoded document? Well, we encode it to look just like an email message. There's headers and there's a body. So there's these headers we put in base 64. It's a Microsoft Word document. And RFC 2046 is going to tell us how to give a file name. It's going to say that if you want to set the file name to this attachment, so we kind of know what it is, we're going to put that in a header called content disposition to be defined in a future RFC. And it does tell us that that field can't contain encoded words, but that's about it. That RFC won't come out for 9 months. So in the meantime, we'll just add some more parameters to content type. Now sure, we've added title here, and title is only going to apply to this one content type, so we have to add it to the definition of every content type, but at least we can put a title on this document. Of course, there's at least one problem here, which is that we've got 8-bit characters again. So obviously content transfer encoding is not going to help because it's not in the body. And right, encoded words, we can't use those in parameters. So we can't use that equals question mark, question mark, question mark, question mark equals thing. So yeah, there's no solution to this problem. You just got to suck it up. Until 9 months later. 9 months later, we get RFC 2148, and it tells us how to encode this. First thing we need to do is add a star. Isn't that nice? put a little star after title, and that says this is going to be encoded. And then after the equal sign, we're going to say it's encoded in UTF-8. The language is English in case you want to translate it or something. And then we're going to have to basically URI encode it. We're not going to use quoted printable because those equal signs, they look a whole lot like parameter values, like foo equals bar, and that's what we're doing. They're going to get confused. And we don't really want to use base 64 because you can't read that easily. So we're going to use %octet. And of course, there's another problem, right? We need to encode those spaces too. So we got to take care of those spaces. It's good to stay human readable, but another problem has come up in the meantime. Remember how we introduced folding because we wanted things to be human readable? Well, everybody got to expecting that to happen. Everybody thought, well, if everybody folds headers, nobody's sending me, headers that are 79 characters long, 83 characters long. They're going to be folded. So we added that so that things would be more human readable. If you want, you can fold things. Well, it's gotten to the point at this time that if you don't fold your headers, stuff breaks. So now you must fold. And if we must fold, that's a pretty long line after having to escape those spaces. But we can't fold this like a header because you can only do folding inside of white space. Header folding is when you take a white space and you make it bigger by putting a new line in there. And we can't do that here. Okay, so let's introduce a new mechanism for folding. It's going to look like this. This title is given to you in 4 parts. Title part 0, encoded. Title part 1, encoded. Title part 2, encoded. Title part 3, 7-bit. If you notice that the 3 is title star 3 equals, there's no star, that's because it's 7-bit. And you see the first one helps us the encoding the language. And we are requested not to change that in the process of these parts. Finally, right about the same time, we've gotten this solution. Content disposition is finally explained to us. We can put content disposition, say this is an attachment. It's not some other kind of content we put in the message. The file name is, here it is, it's in UTF-8. Got the little star there telling us that. But, as long as we're putting this header in here, we can put a lot more information in there. And frankly, I think that there's no reason that we can't just say, we're going to use file attachments as a file system, so let's put the file size on there. Modification date seems like a good idea. It's important to note that the size of the message, that's strictly approximate. You're not allowed to count on it, it's completely advisory, and that comment that I put there is totally legal. Now, one thing I can't do here is put that semicolon. You see this? There's a semicolon now after that size. The variance. That's not legal. Your list of parameters is value, semicolon, parameter setting, you're done. Semicolon's preceded. If you wonder why I'm making a point of this, because it's not that crazy, it's because half the time the RFC that defines this mentions it gets it wrong in the examples. The RFCs get it wrong. Everyone gets this wrong. So you can't reject email because it's wrong. Which means when you parse email, you have to get it right. It's a fact of life. So, all right, let's go back to this email. Let's get back to this guy here. So we wanted to attach that document, right? And we've turned that attached doc file into another email message. So now we need to put those two things together somehow. So we're going to scoop out all the guts of this message. We're going to pull them all out of there. And we're going to put them in another attachment. It's going to look just like what we pulled out. And then we're going to put a content type on the message we have left over, which frankly doesn't seem to have a lot in it. And we're going to say that's going to be a multi-part message. And a multi-part message just means that it's made up of one or more other messages that form its content. And to explain how those messages are going to show up in here, we declare a boundary. So we're going to use that boundary to say content starts here, another one here, and it ends here, for example. It's real simple. A lot of people use very complicated boundaries. I'm using a simple one for the sake of this explanation. Between the boundaries, we have email messages. So we're going to put that main message in there first. It's our plain text message containing the actual message the person is sending. And then we're going to put another boundary and the attachment, right? So I'd be willing to call this pretty reasonable. Say I've got multiple parts, there's a delimiter, and there's going to be a way of saying that this line isn't really the delimiter if it looks like it. So that's not too bad. Of course, you can put stuff before the first delimiter and after the last one. So what is that stuff? Well, content type doesn't apply, because content type applies to the overall thing, saying it's multipart. So we'll assume it's plain text. And it's not going to be 8-bit. And in fact, you're not allowed to use content transfer encoding on multipart messages. So it's probably US ASCII. A lot of people use that to try and do something useful, like say, if you're seeing this, you can't really receive email messages. The best message I ever got that used this was a spam, and it had an HTML part that said, please come by our Vinagre, and the text part that said, please come by our Vinagre, and the preamble which said, get a capable email client. Okay. One last thing. So you see in this, one of the fields that we can put in our RFC 2184 encoded parameter multipart value is language. We're saying this header has been written in United States English. That's a really great idea, isn't it? Don't you wish you could use that everywhere? Well, now you can. If we're going to go ahead and take that message, top level message we had, and let's encode that. So we don't need to, so we're just going to say this is US ASCII, and it's been sort of quoted, printable, encoded. And we really want people to be able to automatically figure out what language the subject was. Well, now we add this. Great. There's a star. It means you know what language it is. Okay. So we've composed a message. It's got a from, it's got a to, it's got an attachment, it's got a body. It's great. This is the best message we've ever had. Now we're going to send it. Okay. So we're going to send some mail. We have a message. We need to send it to someone. So we need their sender and recipient addresses. Okay. I have to digress here because we're going to talk about my favorite thing. Addresses. Oh, email addresses. I love you so. I got this email a while ago. Guy says, I was doing some testing with email valid and I found this. It says that this address is valid. But come on. Come on. That's not a valid email address, right? Well, here's the grammar. Don't worry, I'll walk you through. This is the grammar that governs attr_spec. Attr_spec is the specification for an email address. We can ignore domain literal. So we'll pull that right out of there. Domain literal is for like sending to RJVS at bracket 1.2.3.4 bracket. It means don't look at the MX records, blah, blah, who cares. So we pull that out. And we basically get rid of this. We get rid of dtext, which we don't need anymore. And atom, what's an atom? It's something other than specials. So here are the specials, clean that up. Okay, so let's look at domain. A domain is a subdomain, and then 0 or more sequences of a dot and a subdomain. That seems, right, mentally that seems to me like that's about what a domain is. A subdomain is a domain ref. A domain ref is an atom. And an atom is one or more of any character other than spaces, control characters, or specials. And specials are those ones we see down there. So, these are all valid. If you were wondering why that bottom one is valid, yeah, domain literals kind of have their own rules, so I can put some spaces in quotes and stuff. It's fine. It's cool. Okay, so it's shooting fish in a barrel. It's not really a huge problem in practice. I guess there's probably some idea that if you replace DNS someday, you want to leave the new host names more flexibility than the old host names, and I can appreciate that. So you really always do want to look at the thing after the @ sign and figure it out. So you end up using DNS, and DNS doesn't really hate the living. It's more mild distaste. The real hate in email messages is the local part. And the local part is everything to the left side of the @ sign. So let's bring up the right spec. It's something like this. So a local part is a word followed by 0 or more sequences of dot and a word, and it has to be case preserved. Another great email bug, look how many times you sign up for something on the web, and I'm pretty sure everybody here probably types their email address in all lowercase letters. Look at the mail you get back in and see how many times it's in all caps. That's a violation. I used to lose mail because of that, because I had written email software, to my eternal shame. And it assumed that the email addresses were going to be to me, you know, lowercase r, lowercase j, lowercase b, lowercase s. And here I was getting mail to RJBS. And it was like, that's not me, and threw it away. Great. Okay. A word, all right, and local parts are made up of words. A word is an atom or a quoted string. A quoted string is basically a quote and then anything other than a quote or a backslash, which are used to escape. The backslash escapes anything else, and the quote ends in string. And that includes space, so you can have double quotes with spaces in the middle, anything you want in the middle. So, this is valid. Right? Great. This is, I use that email address. You could send mail, and I'd get it. This is valid too. A lot of people use this kind of system and say, my address plus something else, and it kind of goes to you into a little bucket. This is valid too. I'd be interested to see who accepts that. Totally valid. This is valid. I've been places where that was your email address. And you know, good luck trying to order anything from Amazon. If you want to be a real jerk, yeah, that's valid too. Imagine you get email from that guy. And your program is going to look at that message and try to figure out who it's from. Well, it's from Ricardo, right? Ricardo slash. Buddy. Oh, and it was to this guy. But really, it was to this other guy. That was two headers. I mean, it's not really, right? It's from Ricardo RJBS. Excuse me, Ricardo to RJBS. One of the few people I've ever met with a carriage return as his middle name. That is two message headers, no matter what your software wants to tell you. It's just another vector for abuse. Here's some more. That's valid, right? Now we've introduced the phrase. The phrase is great. It's this thing that goes in front of the address, and it tells you, usually, who the person is you're sending to. So, first one, a phrase in an angle adder, totally reasonable. Next one is just showing us two of them. You can put them together with commas. I think that's fine. A third, an infrequently seen form of email technology is the address group. Address group is a name, and then a colon, and then a list of email addresses, and then a semicolon. So, this is going to a bunch of people who are known as the technical staff. And the technical staff, because that R and D in the middle, that's a comment, right? That goes away. And it contains two people. Okay. Here's another one. Let's play a game. Everybody here has been paying attention, right? You've all implemented RFC 282 compliant email address parsers by this point, I assume. How many valid email addresses are on this slide? Anyone? See, two? Two. Okay. What are they? Okay. Let's walk through them. First one we see there is an address group. Seems to contain two addresses. Well, that first address, that's no good. RJBS.@CPAN. You can have dots in your local part, but they can't be the last character. Also can't be the first character. HTTP:work. Can't have colons right out. Characters. There's Van Helsing. Van Helsing looks pretty reasonable, right? But there's no dot here. That's an 8-bit character. Sorry. That's not valid. Dude, you can't even send this message anymore. The invisible man who's not there, he's really not there. He's inside parentheses. He's just a comment. So what do we have now? We have an address that's kind of bogus, and then a comma, and a comment, and another comma. Well, that's cool. It's just like Perl, right? You can have as many commas as you want. They don't mean anything. They separate, 0 or 1 addresses. Then we've got a phrase for our alizo. And alizo is not valid because that fully qualified domain name, well, that might be valid in DNS, but it's not valid in email. You can't have that trailing dot. So the only valid email address on this slide is that last one. You can also nest address groups. Only in RFC 724. RFC 822 doesn't really address it very well, and in 2822 it's not legal. So this would be completely valid email, because something else you might be interested in is people talk about RFC 2822 and RFC 2821 as being the modern, more sane forms. This is what we'll adhere to, but they're actually not accepted standards. I know the IETF is weird. Some things they call accepted, some they call draft, but 2822 is really sort of pretty draft status, even though we try to stick to it. You really need to stick to 821 and 822 because those are really widely deployed standards. So this seems like something we actually need to try and parse. And we're going to fail because it has multiple failures. But we need to keep going because somebody's going to send you this message. Somebody's going to send you this message. You're going to think you're supposed to accept it because you're going to misparse the thing intentionally because you want them to know. Of course, this actually isn't valid because we've nested those address groups, right? An address group is a name and a colon, and then a bunch of stuff, and then a semicolon. And we've got a nested group, but only ended with one semicolon there. So we need to have that, or we're... and that means there's one other group. And this is actually, here's the one useful thing you guys can all take out of this talk. That's valid. It's valid, and it's actually useful. Modulo the name of the group, undisclosed recipients, call it whatever you want. That is the only way to produce a valid email message that does not have any recipients. So if you're trying to send a message and you want to BCC everybody in the message, or you are trying to send a message and you don't want to have a header that has a person's name where it's expected, that's what you have to do. Of course, I would suggest that if you were trying to send a message and you are doing it with something other than MUT or a mail app, you are losing the game already. Okay, so back to SMTP. Like what, 8 minutes? I don't think that's enough. So I think you guys are going to have to wait until next year. We'll talk about SMTP then, and I'm going to make it short. Who dares ask a question? Yes. Todd? Is it Todd?
It is Todd. So at work, we bought an application, the email list, and I was having a problem with it, so I timidly stuck my toe into the RFCs, got thoroughly confused. Maybe you can enlighten me.
Don't bite me.
Go on.
Header line folding. There also seems to be some statement about length of header, but it's confusing as to whether that length applies after you've unfolded the line, the header line, or not. Okay,
so I'm going to restate your question completely differently.
Please.
What's the deal with header line folding? It's something like this, to give you more specifics on how it works. Folding header lines, other than parameter values, is optional. You are expected to do it. I think the spec probably says something like, wherever. Something like at 72 characters or 79 characters. And that refers to the entire logical length of the line, which means that if you have a header name that's foo-bar-baz, I'd count that. But like I said, it's totally optional, so where you put the break is up to you. If it were up to me, and everything, accepted everything, I would never have folded my header lines. Another issue that comes up that I didn't mention is that when you fold a header line, you generally do that by finding a place where there was a space, and you put a character turn, and then a space, and you keep going. But you can put as much space on either side of that character turn as you want, and it gets compressed down into one space. And that means that if you had something where you needed more than one space, you've lost it. There's no way to ensure wide amounts of space in headers other than by encoding the literal octets. Ugh. Was there more to that?
What I'm interested in is slightly different. Somebody somewhere out there in the world crafts an email message to a very, a simple, uncomplicated email address, comma, another one, and they've got 500 email addresses on the to line, and their application has folded it, so there's email address, fold,
Sure.
email address. And so this goes on down. So nice short lines, no
Yeah.
complications, whatever. And the application we bought buys it, and brings it in and says, oh, this is a folded header line, I'm going to unfold it. And so it unfolds and gets one long character string, 500 addresses in it. And then it says, oh, this is longer than something I believe to be the maximum length of a header line, so I'm going to truncate.
That's an interesting question. I don't know of any maximum length for a header. There very well may be one. But if there is one, I don't know of it. And I would suggest that in modern email, another point to Wayne pragmatic for a moment. The point is with email, the specs are all crap. You can't trust them. You can barely deal with the specs and expect anything to work. What you really need to do is do whatever works. And I kind of hate doing that in enterprise professional code, but with email, that's the mandate. So what I would suggest is do something to keep that software from unfolding it and breaking it. I don't think there's any real limit to length of headers. And if there is, I would suggest that very little worthwhile software enforces it. Anybody else? Yes?
What is the appropriate snappy retort to a manager who asks you to add email address validation to an application?
Yes, sir. Email address validation is impossible, but that doesn't mean it's not worth attempting. I maintain email : valid. I didn't write it. I just like a lot of email software. I just apply patches. But I can tell you that it's quite good. Like I said, if you try to validate it based on the grammar, you can do it, but it doesn't tell you a lot. But you can go further, right? You can say, well, what is the domain? Okay, is that a valid domain? Does that domain name exist? Does it have an MX record? Is it in our list of bogus known addresses? And for the local part, like I said, where I work at Pobox, we deal with a lot of mail, and the general standard is whatever comes in, if we're just going to forward it on, we will generally try and assume, okay, it looks good enough, we'll keep sending it. And if somebody says, I want this email address, like I want to use this as my username, we apply a much stricter set of rules. So like with everything else, it depends on what you're going to do. If you're getting a user who wants to sign up and you think their address is crap and you're not going to be able to send to it, limit as much as you can within reason. But I think that the snappy response really is, yes, sir, you have to validate email addresses. If you don't validate them, you will accept garbage. You will try sending mail. It will sit on your MXs. You'll have to do much more bounce parsing, which is a whole other sequel to this. So it's definitely worth doing, even though it's a pain in the butt. Anyone else? Yes?
Just to confirm my fears, I saw that you were doing file name in the attachment section. I was wondering if even on multi-line applies to that as well, right?
So does multi-linitude apply to file naming? File names, the most correct place to find a file name is in the file name file name parameter to the structured content disposition header. It is a parameter, which means it does the encoded with an asterisk thing, and it does the split into multiple parts with an asterisk thing. So if you have a very long header, you must encode it if it has 8-bit. You must split it across lines if it is splittable on white space, and if it's not, you must do the *0, *1, *2. Other interesting things about the file name field, it's only supposed to refer to the leaf. It's only supposed to refer to the leaf file, and it can't be restricted that way. So your software has to make sure you don't blow things away. Okay, I'm being told I'm over time. Thank you very much.